Good morning. Good morning, students. Structure of atom. Okay. So today will be last one. So that is structure of atom. So good morning. Okay. So what we had discussed in the last class? Any one of you? Hmm? So what we had discussed? Okay, yes, very good. So we had discussed about boundary surface diagrams, right? Very good. So we have discussed about the boundary surface diagram. Yes, all of you are right. Yes, very good, Suchita. Yes. Then we have discussed about nodes, right? So in that we have two types, radial nodes and angular nodes. Okay, so sometimes in a hurry I might have written angular nodes like this, don't get confused. So but don't use the short form. Okay, so I think yesterday while explaining I might have written angular nodes like this. So in your examination you should not use the short form. Okay, so that's where we have the two types of nodes. So in that case, what do you mean by boundary surface diagrams? So boundary surface diagram means these are the shape of the subshells, or I can tell boundary surface diagrams are those which will be covering those regions where probability of electrons will be high, and each subshell will have different shapes based on their boundary surface diagram. For example, if I take S, it will be having spherical shape, right? So if I take P, it will be having dumbbell shape. So it will be having dumbbell shape, right? So that's where dumbbell shape. So if I take D, it will be having double dumbbell shape. It will be having double dumbbell shape. So what I mean to tell you is that's why spherical shape. So that's why dumbbell shape, and that's where we have the double dumbbell shape. But in case of the D subshell, we have one of the orbital which is having a different shape. Which is that? Name of that orbital which is having a different shape totally. Otherwise, all of them they are having double dumbbell shape when it comes to D subshell. But which is that one? Yes, Sahana, very good. So that is dz square, which is having this type of structure, right? Which is having this type of structure. If I consider this one as the z axis, this one as the z axis. So that's where I have the dz square. Shashank, D should be small letter, okay? So D should be small letter, that's fine. While typing you might have done the error, but it should be information, it should be small letter, okay? So that's where we have the shape of the orbitals with respect to SPD orbitals, okay, or subshells. Now when it comes to nodes, so what are nodes? So these are the regions. Okay, cosmic razor. What do you mean by ACH? In biology, ACH means acetylcholine, a short form. ACH, a neurotransmitter. Now, just I am making a fun. Okay, you had written ACH, some cosmic razor. Okay, so ACH, that's what biology students they will agree with me. Acetylcholine receptor, ACHR, we will write, right? Okay, so that's where we have the nodes. So what are nodes? So these are the regions. surrounding the nucleus where probability of electron, finding the probability of electron will be almost zero. Okay, it is almost zero. That word almost zero is important. Okay, all of you have agreed? So that's what we have discussed. Now when it comes to radial nodes, S subshells or S orbitals are the one which will show only radial nodes. No question of angular nodes with respect to S subshell orbitals. Now when it comes to angular nodes, it can be shown by P also, D also. It can be shown by P also, D also. And here also, radial nodes can be shown by P and D also. But S cannot show the angular nodes. Okay? So that is one thing. Same way, when I am talking about 1S, where there will not be any nodes, no nodal region, so no nodes. So that's what total number of nodes, n minus 1. So 1, n minus 1 is 1 minus 1, 0, right? So that's where no nodes with respect to 1s. Okay? Same way when it comes to 2p. Anyway, we don't have 1p at all. So when it comes to 2p, so in this case, there will not be any radial nodes. That's quite common. Only one angular nodes will be there. So that's where n minus 1 is equal to total number of nodes. N is 2. So 2 minus 1 is 1. So naturally, only one angular nodes will be there with respect to 2p. So that's what we had discussed in the last class. So which is that equation? That is total number of nodes will be equal to n minus 1. So total number of angular nodes. See here, I am writing the short form, but don't write this one. So that is equal to azimuthal quantum number. So total number of radial nodes, in that case it will be total number of nodes minus angular nodes. So that will give the total number of radial nodes. All of you have understood? This is what we have discussed in the last class. Any doubts with respect to the last class? Whatever concept we have discussed, all of them, they are important. 1 mark question you can expect. Even for competitive exams, they have asked about all these things. Okay? So any questions, any doubts? Okay, fine. In that case, we will move to next one. Okay? So now, when it comes to next concept, we have one thing. Dikshit. Oh, okay. Good morning. Okay? So in that case, we have a particular term called as degenerate orbitals. So these things you can expect for 1 mark question. So degenerate orbitals. When I am talking about degenerate orbitals, now you can tell that these are the groups of orbitals. These are the groups of orbitals. Okay, or group of orbitals having, okay, I will write it here, having same energy. These are the group of orbitals having same energy. So that's where we have the degenerate orbitals. Okay? So that's where we can define it. Okay? So when it comes to hydrogen atom, When it comes to hydrogen atom, can any one of you tell me what is the total number of electrons present in the hydrogen? What is the total number of electrons present in the hydrogen? Can any one of you tell me? What is the total number of electrons? Yes, Stephen, absolutely right. It is 1. Hydrogen is having atomic number as 1. So naturally, it will be having 1 proton, which will be equal to 1 electron. That means hydrogen is having only 1 electron. Yes, all of you are right. Yes, absolutely correct. So that's where we have the hydrogen atom. Now whatever I will be talking at present, it will be applicable for hydrogen atom. Okay. So according to, with respect to the hydrogen atom, I can tell that 1s is of lower energy. 1s will be of lower energy. Then comes the 2s. Then comes the 2s. And since at energy level 2 we have p subshell also, so that's what 2s and 2p, they will be having equal energy, but it will be greater than that of the 1s. Same if I go to next energy level, so 3s, which will be equal to 3p, which will be equal to 3d. So that's where it will goes on. It will goes on because we know that in a atom, so we have different energy level. So when I am talking about first energy level, only s subshell is available. So when I am talking about second energy level, s and p is available. So when I am talking about third energy level, spd are available. Fourth energy level, S, P, D and F. Like that it will goes on. So that's what I have written. First energy level, it will be of lowest energy. So 1s, which will be lesser than that of second energy level, where 2s and 2p, but they will be of equal energy. Now when it comes to third energy level, 3s, 3p, 3d. So 3s, 3p, 3d. So when it comes to fourth energy level, 1, 2, 3, 4. This is fourth energy level, right? So 4s, 4p, 4d, 4f. So even I will go with fourth one also. 4s, 4p, 4d and 4f. So that's where we have the hydrogen. With respect to the hydrogen, please remember whatever I am talking here is, it is with respect to hydrogen atom only, where we have only single electron. Now if you observe it carefully, 1s and 2s, they cannot be degenerate orbitals. 1s and 2s, they cannot be degenerate orbitals. Or 2p and 3s, they cannot be degenerate orbitals, because definition of degenerate orbitals tells that these are the group of orbitals having same energy. They should have the same energy. Since 1s is of lower energy compared to 2s, they cannot be the degenerate orbitals. However, whatever I have written on the board, among that I can tell that, so 1s and 2s and 2p, so 3s, 3p and 3d, 4s, 4p, 4d and 4f, they are all can be considered as degenerate orbitals. All of you have understood? So 2s and 2p, equal sign is that. 2s and 2p, they can be degenerate orbitals. 3s, 3p, 3d, they can be degenerate orbitals. Same way, 4s, 4p, 4d, 4f, even they can be degenerate orbitals. But once again I will be repeating, but this is applicable only for a hydrogen where only one electron is present. It's not applicable for all the other elements. It's applicable only for the hydrogen. So that's where I can tell that These are the example where 2s and 2p and 2p. Same way 3s and 3p and 3d. Same way we have the 4s, 4p, 4d and 4f. They are all degenerate orbitals. Okay, this is another set of degenerate orbitals. And this is another set of degenerate orbitals. But it is applicable. It is applicable. It is applicable only for hydrogen atom. Whatever I have written, examples for degenerate orbitals, it is applicable only for the hydrogen. Okay? No, Rohan, I will come to that. I will come to that. Definitely there will be power, but I will come to that. Okay? So why that difference? Why it is applicable only for hydrogen? I will come to that. But this much you have understood? All of you have understood? Any doubt in this? So therefore I have made a statement. It is applicable only for hydrogen atom. If in the examination for 2 marks, if they have asked, what are degenerate orbitals? Give an example. Then you can tell that definition of degenerate orbitals. Then you should give the example any one of these. For example, 4s, 4p, 4d, 4f will be degenerate orbitals, but you should mention that in the hydrogen atom. You should mention that in the hydrogen atom. Then only it will be correct. Otherwise, it will be a very wrong statement. Okay? All of you have understood? Shall I move to the next one? Shall I move to the next one? For hydrogen, we have seen what will be degenerate orbitals. Shall we move to the next one? Okay? So, if I come to next other elements, because we have plenty of elements, not only hydrogen, we have plenty other elements. So whatever I am writing, it is applicable for elements containing more than one electron. So whatever I will be writing, it is applicable for all those species which are having more than one electron. You can move to the next one, sir. Yes, Rohan. Okay, that's where we have the next concept. There also we have degenerate orbitals. There also we have the degenerate orbitals. Say for example, 1s as usual, it will be of smaller energy. Then comes the 2s, it will be of bit higher energy compared to 1s. Now observe it carefully. We have 2p, which will be bit higher energy compared to 2s. Which will be bit higher energy compared to 2s. Then comes the 3s, then 3p, then 3d. Same way we can go with 4s, 4p, 4d and 4f. So what is happening? We can see that in the same energy level, there is a difference in their energy, right? So this belongs to energy level 2. So this belongs to energy level 3 and this one belongs to energy level 4, right? But still they are not equal. Right? So that means they are not the degenerate orbitals when it comes to other elements, when we have more than one electron, where we have more than one electron. So that's what I mean to tell. Illi naan correct agi idar prakara bardilla. If I want to go with exact this one, I should follow Aufbau principle. So according to Aufbau principle, we have 1s, 2s, 2p, or Aufbau diagram. So 3s, 3p, then 3d, 4s, 4p, 4d, 4f, 5s, okay, I will come reverse, okay, 5s, 5p, 5d, 5f, like that if I go, or I can make it as reverse also, it will be easy for you, anything is fine. Now I am talking about off-bow diagram, okay. So like this we can go, or in a reverse order we can come. Okay, in a reverse order also we can come. That means we can write 1s first, then comes the 2s, then comes the 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. Okay, so whatever I have written, it is nothing but off-bow diagram. Okay, it is off-bow diagram. Okay, sir, greater than or less than? Oh, okay, very good observation. It should be greater than. Anyway, so this is not, will not go with applicable. This will follow off-bow diagram only. So that's where we have the off-bow diagram. Whenever you are writing the electronic configuration, I will teach you that one. You have to know this. Now observe me carefully. First, lower energy is going to fill up, that is 1s. Lower energy is going to get filled up with respect to electron, lower energy. Then comes the 2s. Okay, so then comes the 2p, then 3s. So from 1s it will go to 2s, from 2s it will go to 2p, from 2p it will go to 3s, then it will come to 3p and 4s. Observe it carefully. So from 4s it will go to 3d, 4p, 5s. So from 5s it will come to 4d, 5p, 6s. So from 6s it is moving to 4f, 5d, 6p, 7s. Like that it will move on. All of you have understood? So what is happening here? From 1s, which is the lower energy, then electron move to next energy. Once it is getting filled up, it will move to 2s. Once 2s is filled up, it will move to 2p, then 3s. So once 3s is getting filled up, it will move to 3p. Then it is coming to 4s, not to 3d. So 4s, after that it will come to 3d, 4p, 5s. Then it is moving back to 4d. So before 4d, 5s is getting filled up. So if I want to go with off-bow diagram, which is the exact explanation for this. So according to that, I can tell that if this is the energy level, as you move up, energy is going to increase. As you move up, energy is going to increase. So according to that, 1s is somewhere here. Okay? So then comes the 2s, which is somewhere here. Then comes the 2p, 1, 2, 3 orbitals, right? So 2p. Now if I come to 3s, then 3s comes, 1 orbital. So then comes the 3p, which will be a bit higher one. 1, 2, 3. Then comes the 4s. So right, then comes the 4s. So then comes the 3d. 1, 2, 3, 4, 5, because 5 orbitals will be there, right? So then comes the 4p. 1, 2, 3. Like that it will come. So like that distribution will happen. So what we can observe? So 1s will be lower energy compared to 2s. 2s will be of lower energy compared to 2p. 2p will be of lower energy compared to 3s. 3s will be of lower energy compared to 3p. 4s will be lower energy compared to 3d. 3d will be of lower energy compared to 4p. Like that it will go on. Okay, according to off-bow diagram. Okay, so now I can tell 1s, it will be of lower energy. Yes, I will be writing the proper symbol. 1s, then comes the 2s, then comes the 2p, so then comes the 3s, so then comes the 3p, right? So then comes the 4s. So once 4s is done, now comes the 3d, okay? And then we have the 4p. So like that it will goes on. So like that it will goes on. All of you have understood? Yes, Chidwan, I was expecting this. Yes, before filling of 3D, 4S will fill up. That's what it will happen. That's how off-board diagram is going to explain. So whenever we are writing the electronic configuration, we have to follow this particular diagram. So before getting filling of 3D, 4S is going to get filled up. Okay, that's how the electron will be distributed. That is because suction. I will come to that. That is because of the suction, SPDF. Due to that, this will happen. I will come to that point. Okay, but for timing, you should understand that for the other electron, where more than one electrons are present, this rule is applicable. Now, can you tell me any degenerate orbitals are present here? Not off-bow, it is off-bow. Okay, it is off-bow diagram, AFBAU. It's there in your textbook, don't worry. You have to practice this. Okay, so in that case, if you know this one, any atomic number if they give, to write the electronic configuration, you can easily write the electronic configuration without any mistake. Only thing is you should practice off-bow diagram. Off-bow is not a person name. Off-bow means, I think in Germany or in some language, off-bow means to building up, to build it up. Okay, so that's why off-bow stands for. It's not a person name. Okay, so no degenerate orbitals. No, I will tell that there will be presence of degenerate orbitals here also. Yes. According to me, there will be presence of degenerate orbitals here also. Anyone? Which can be those? No, Likita. There will be presence of degenerate orbitals. When you say yes, it looks like no degenerate orbitals, but I am telling there will be presence of degenerate orbitals, and I have written it on the board also. Just you should observe. No, how come 1s and 2s? They are of different energy. No, Chidwan. Anyone? No. 1s, 2s, 3s, 4s? No. How it's possible? 1s is here, 2s is here, 3s. They are totally different. Yes, very good answer. Thanmai, right? So very good answer, very good. So if you observe it carefully, I told I have written it on the board. See here, 1, 2, 3. That means 2ps is equal to 2py is equal to 2pz. They are the degenerate orbitals. They are the degenerate orbitals. Same way, if I come to here, we have 3px equal to 3py equal to 3pz. They are the degenerate orbitals. So same logic, 3d. So when I have 3dxy is equal to 3dxz is equal to 3dyz is equal to 3dx square minus y square is equal to 3dz square. They are also degenerate orbitals. Can you see here? I have written all the 5 orbitals at same level, same height. So all the 3 orbitals at same height. All the 3 orbitals same height. So that's where they can be the example for degenerate orbitals. So energies of the orbitals in the same subshell decrease with, oh, we have written this one. Increase, yes, that I agree. That we have discussed when we were talking about hydrogen spectra. During that time I have explained. Now my question here is, any degenerate orbitals are there? Yes, they are the example. What I mean to tell here is, when it comes to other elements other than the hydrogen, we can tell that orbitals present in the same subshell, listen to me carefully, orbitals present in the same subshell can be the degenerate orbitals. Like in 2p, we have 2px, 2py, 2pz, three orbitals are there. All of them will be of same energy. Same in 3p, we have three orbitals, 3px, 3py, 3pz. All of them will be of same energy. So that's where we have the degenerate orbitals. All of you have understood? So this is applicable when I am dealing with other elements other than the hydrogen. All of you have understood? Any doubts? Sir, I did not understand where are degenerate orbitals. Rohan, when I am talking about 3p or 2p, I will take 2p. So I told yesterday that there will be three boxes and each box will be representing orbitals, right? Anytime I had written 2p as like this, one box here, another box here and another box here, like that we have written? No, we have written in the same line, okay? So that's where they can be degenerate orbitals. Those individual boxes, they are nothing but orbitals only. Rohan, whether I am clear now? Have you understood? So that's where I mean to tell degenerate orbitals, that these three boxes 1, 2, 3, 2px, 2py, 2pz. So 2px, 2py, 2pz, they are in the same energy level. Now whether I am clear, Rohan? Any doubt? This is applicable for other elements. Okay, done. Okay, done. So in that case, if you have understood, please practice a board diagram. Okay. So when you go home, even you can find this one in your textbook also. This diagram. Any of the chemistry textbook, you can find the off-board diagram, because that is very much required to write the electronic configuration for a element. Now, I will come to a point where Rohan had asked that, Rohan or I think Chidwan, someone had asked just now. They were asking that, sir, how come before 3D 4S will get filled up? That was the question, right? Now to understand that, we should see some more explanation. For example, we have another concept called as shielding effect. We have another concept called as shielding effect. What do you mean by shield? Shield means a protecting cover, right? So that's where we have the shielding effect. When you are riding the vehicle, bike, we have to wear the helmet because it will act as a shield to our head. That means it will protect our head from the injuries. So that's where we have the shielding effect. So shielding effect, once again, it is applicable for all the element other than the hydrogen and hydrogen-like species. Shielding effect, it is applicable for other than those elements other than the hydrogen or hydrogen-like species. Why? Because hydrogen or hydrogen-like species, they will have only one electron, where we cannot observe shielding effect and all. Okay? So what do you mean by shielding effect? First I will explain, then I will define. See, we have the energy level. We have the energy level. So that's where in a multi-electronic species, I have 2 electrons, and we will imagine in this particular element we have around 11 electrons. So that's where 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 electrons, then another 1 electron. That means I am talking about sodium. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how electrons will be distributed. So you will understand why I have shown only 8 electrons here and all, you will understand. Okay, that one I will explain when I will be talking about electronic configuration. So if you observe this particular distribution of electron, now all of us we know that that's where Rutherford's and Bohr's atomic model. Sir, circle are too light. Okay, so I will make it dark. But electrons can be seen. Okay, so I can understand. Okay, and this is the outer energy level. Anyway, there is no electron, but simply I have written this particular circle. Okay, done. Okay, so in that case, if you observe here, all of us we know that Bohr's atomic model and Rutherford's model, that's where they were correct, where they told that electrons will be revolving around the nucleus. Electrons will be revolving around the nucleus. That is 100% correct. Right? So that means all these electrons, they are revolving around the nucleus. They are not constant. They are not constant. They are not standing at one position. They will be revolving. Right? So in that case, one thing you should understand here, that as you move away from the nucleus, velocity of the electron is going to change. It will not be constant. All the electrons will not be revolving around the nucleus in the same velocity. So they will be having different velocity, and also distance is also different. Here it is a small path. Here it is a bit larger path. Here it is much more larger path. So therefore, that means all electrons, they can interfere with each other with respect to nuclear force. They can interfere with respect to their nuclear force. If for example, I have the inner shell electrons, they will be feeling some nuclear force acting on them. Same way, nuclear force will be acting on these electrons also. It will be acting on these electrons also, and even on the outermost electrons also, nuclear force will be acting. All of you will agree? Okay? So that dotted arrow I am indicating about the nuclear force. It is acting on here, and all these electrons, even for outer electron. Now if you observe it carefully, inner shell electron is the only electrons which will be feeling 100% nuclear force. Inner shell electrons are only those electrons which will be feeling 100% electron force. Yes, Tanay. So that's where these two electrons are the one which will feel 100% nuclear force acting on them. But when it comes to these electrons, there will be some interference by the inner shell electron. They will be disturbing. Here and there about these nuclear force. They will going to disturb. And when it comes to this outermost electron, these two and these 8 electrons, all of them, they are going to interfere with the nuclear force acting on the outermost electron. All of you got my point? Whether people are understanding? Okay. Say for example, I have a magnet. Okay, I have put one iron nail over here. Okay, I have put one iron nail over here. Now I will keep another iron nail here. Naturally, the magnetic force will be interfered, which is acting on this. It will be interfered by the iron nail present over here. Okay, so this iron nail is going to interfere with the magnetic field acting on this particular iron nail. Same logic is applicable here also. Okay, so whatever inner electrons are there, they are going to interfere with the nuclear force acting on the outer electrons. And these all together electrons, they are going to interfere with the nuclear force acting on this electron. Got my point? So that means as the electrons will be moving away from the nucleus, that means they will be having more shielding effect by inner electrons. They will be having more shielding effect acting on them due to the inner electrons. So what I mean to tell here is, you imagine that no electrons are present, only this electron is present. Imagination. So no electrons, only this electron. So in that case, amount of nuclear force acting on them can, we will imagine, I will give just number, don't take it as proper one. We will imagine no electrons, only this electron and nucleus, this will be, value will be 10. That force value will be 10. But now, when these electrons are present, due to the shielding effect, so it will get reduced to 2. It will get reduced to 2. Nuclear force is getting decreased. Yes, iron which is close to the magnet will have the higher magnetic force acting on them, no doubt. Even the magnet INL which is far from the magnet will have some magnetic field, but even that amount of magnetic field will be slightly decreased if you keep another INL in between those two. That's what I mean to tell. Got my point? So in the absence of all these electrons, if I consider only this electron at this energy level, which is impossible, but still we will imagine. So no electrons are present here, only this electron which is present at energy level 3 and a nucleus. Then the amount of nuclear force will be 10. Now, if I put all these electrons inside, then the nuclear force will become 2. That means outer shell electron nuclear force is getting decreased than the expected one. It is getting decreased than the expected one. All of you have agreed? All of you have understood what I mean to tell? Okay? Any doubts in this explanation? Now I can define the shielding effect. Okay? So now I can define the shielding effect. This is the decrease in the amount of nuclear force. This is the decrease in the amount of nuclear force acting on the outer electrons or outer shell electrons due to interference of inner shell electrons. That will be the shielding effect. So what do you mean by shielding effect? You can tell that shielding effect is the condition where inner shell electrons will going to interfere with the nuclear force acting on the outer shell electrons. That is also fine. So what do you mean by shielding effect? Shielding effect is nothing but interference of the inner shell electrons with respect to nuclear force acting on the outer shell electrons. That is also fine. Or this is the decrease in the amount of nuclear force acting on the outer shell electrons due to interference of the inner shell electron. So that's where these inner shell electron will act as a shield for the outer shell electron against the nuclear force. So therefore it is called as shielding effect. Shuchita, whether I am clear? So what I mean to tell here is these inner shell electrons, they are masking some amount of nuclear force, they are masking. So all the nuclear force not applicable to this particular electron because it is interfered by the inner shell electron. That's where they will act as a shield. Or to be more appropriate example I can take is ozone layer. Right? All of us will know because we are facing with the global warming. Right? So when I am talking about this particular concept, I can apply the same logic there. So sun rays, they are coming to the earth, but 100% sunlight is not going to reach to us. 100% energy of the sun is not going to reach to us. That is because shielding effect shown by the ozone layer. So what ozone layer will do? They will take up some of the energy and it will allow only left amount of energy to enter into Earth's surface. That's why we are saved. Otherwise, if there is no ozone layer, no one would have survived. Okay? All of us would have been X-Men. Have you seen X-Men movie? Mutation. Mutated species. Which is not possible. That is all imagination. But only thing is fantasy. So that all of us would have become X-Men. Because all of us, our gene would have been mutated. Naturally, we are going to die because of cancer or some other disease. Right? So that's where we have the that's where we have the shielding effect shown by the inertial electron on the outer electron. So these two electrons will have the shielding effect on these electrons. So all these electrons will have the shielding effect on these electrons. So that's where we have the concept called as shielding effect, which is applicable when we have a multi-electron species. All of you have understood? This concept you have understood? So this is one of the reason why there is a difference in the energy. That is one thing. Yes, it can lead to skin cancer. Yes, if ozone layer is getting decreased, ozone hole. Yes. Okay? Fine. So this is one of the important concept. Now we have another important thing. Oh, I removed this one as fine. So we have another important thing. One is due to the shielding effect. That's where we can see the difference in the energy distribution of electrons. Okay, that is one thing. And another thing which is going to have the impact here is shape of the orbitals. Another thing is shape of the orbitals, which is also having the impact. With respect to shielding effect. See, for example, I have S subshell, which is spherical in shape, and I have P subshell, which is dumbbell in shape. Then I have D subshell. I will not go with F. I have D subshell, and this is where we have the D subshell. Now, if I see these three orbitals or subshells, I can see that electrons which are present in the S subshell, they are at constant distance from the nucleus. There is no variation. They are at constant distance. They are near to the nucleus. At all the time, they are close to the nucleus. All of you will agree? But when it comes to S subshell, there is a variation. They are coming and they are going away. Once again they are coming near. Once again they are going away. Once again they are coming here, and once again they are going away. So that means there is a lots and lots of variation is there. That's where F subshell is not required, because shape is not there for you people. Only sentence I will tell at the end. Okay? So in P subshell there is a variation. It's not constant as that of the E subshell electrons. Now when it comes to D, here much more variation is there. So electrons will be far. It will come here, once again far, it will come here, once again far, it will come here, once again far, it will come near to the nucleus. So lots of variation when it comes to D. And when it comes to F, too much variation. The variation of electron from the nucleus distance is going to vary a lot. Got my point? Only S subshell electron is the one which will be having closeness to the nucleus at all the time, no variation. But when it comes to B, variation is there. When it comes to D, much more variation is there. All of you have understood? So therefore, if I take the nuclear force, then I can tell that S subshell electrons will feel more nuclear force compared to P subshell electrons, which will be feeling more nuclear force compared to D, which will be feeling more nuclear force compared to F. All of you got my point? So that's where I am talking about nuclear force, not the energy level. Okay, I am talking about the nuclear force. So with respect to the nuclear force, I can tell that S subshell electrons will feel more nuclear force because of spherical shape. Means not the shape of the electron, shape of the orbital. So S subshell electrons, since they are at constant distance from the nucleus, they will feel more nuclear force compared to electrons present in the p subshell, compared to electrons present in the d subshell, compared to electron present in the f subshell. Okay, so that is also one of the reason. That is also one of the reason why we can see the difference in the electron distribution, which is also decided by which subshell. Okay, all of you got my point? Any doubts in this? Any doubt? Since S subshell is having spherical structure, since electrons are at constant distance, that's where they will be close to the nucleus, and p subshell electrons, since there is a variation with respect to the nucleus, since there is a variation, so once they will be here, once they will move here, once they will be here, once they will move here, so constant variation is there, so they will feel bit less nuclear force, and then comes more less nuclear force with respect to d subshell electron, like that it will go on. All of you have understood? So therefore, in the next year, in p block elements and all, you will come across this concept once again. You have to apply this concept over there. So now I can tell that when I have the outermost shell, you will imagine I am talking about 5s, 5p, 5d and all. Outermost energy level. Now I can tell that in this particular, this one, 5s electrons will feel less shielding effect compared to 5p. 5p electrons will feel less shielding effect compared to 5d. Like that the explanation will go on. Or I can tell that in the outermost shell, or when you go away from the nucleus, so S subshell electrons are the one which will feel less shielding effect compared to other subshell electrons. That's what you can keep it in your mind. When you move away from the nucleus, so S subshell electrons will be the one which will feel less shielding effect compared to other subshell electrons. All of you have understood? So I will make a statement. Therefore, S subshell electrons will have or will feel less shielding effect, acting on them, less shielding effect acting on them. All of you have understood? So these are some of the points. We are going to apply all these things in your next year, some of the topics. Okay? So whether I am clear? So very important one is shape of the orbital, which is also going to have the impact. That is one thing. Now, another important point here is, when it comes to multi-electronic species, another important point here is presence of electron repulsion. So what I mean to tell here is, in a multi-electronic species, they will not be like hydrogen, because in the multi-electronic species there will be shielding effect, and shape of the orbitals they are going to have the effect. Then electron repulsion will have the effect. So due to all these reasons, in a multi-electron species, they are not going to have same arrangement as that of the hydrogen or hydrogen-like species, where only one electron will be there. Whether I am clear? Any doubt here up to here? Any doubt? So if you don't have any doubt, shall I move to the next one? Already it is nearly 9. Shall I move to the next one? Okay, last one. So that is N plus L rule. It talks about N plus L rule. See, for example, I have 4F, 4S and 3P. I have 4s and 3p. Now can you tell me what will be the total value for 3s and 4s and 3p by considering the value of L and principal quantum number? What is that? 3p and 4s. If you consider the value of azimuthal quantum number and principal quantum number, if you add it up, what will be the value? Answer. Any one of you? I have 4s and 3p. Among these, if I consider the value of principal quantum number, that's what? And azimuthal quantum number, if I add it together, what is that answer you are going to get? Anyone? If I add these two, 4s and 3p, okay, p is equal to 6. No, Stefan, you are not getting the point. No, you are not getting the point. See here, I am asking S, P, D and F. What is the L value for S? It is 0. What is the L value for P? It is 1. What is the L value for D? It is 2. What is the L value for F? It is 3. So those values you should put. N plus L. N is equal to 4. L for S is 0. So the answer should be 4. Right? Here. So N value is 3. What is the P value? It is 1. That is equal to 4. That is equal to 4. Now what we can do? N plus L rule. According to that, normally, is it 7, sir? No, Rohan. How can it be 7? Don't count the orbitals number. Just take those values which we have already discussed. For S subshell, the value of L is 0. For P subshell, the value of L is 1. If you go back to day before yesterday's class. For the D subshell, the value of L is 2. For F subshell, the value of L is 3. So you have to utilize those values. So with respect to that, N plus L, where N is 4, L is for S it is 0. So it will be 4. For N plus L, 3P. So N is 3. L is P, that means 1, that is 4. So they are having same N plus L value, that is 4. They are having same N plus L value, that is 4. Okay? Now remember this. Tomorrow I am going to explain further. Okay? It is 4 and 4. Yes. So remember this. And practice the Aufbau diagram. Okay? So once again, Aufbau is not a person's name. In the German language, if I am right, it is nothing but to get build up, building something. So what they are building? Energy levels. They are building the energy levels. Okay? So anyway, tomorrow we are going to continue. I thought today I will finish it off. Don't worry, tomorrow we are going to finish it off. But all these things you have to practice and you have to understand. Then you can understand chemistry a bit easily. Okay? Otherwise it will be very difficult. Okay. So thank you. Thank you very much. Yeah, it is in German. Okay, then fine. I am right only. It's in German. It's like to building it up. Okay? So thank you. Thank you. Thank you very much. Take care. Okay? Okay. Thank you. So tomorrow we will finish 100%. Thank you.